Hello everyone, and welcome to part 4 of the Python Crash Course lecture series. In this series of lectures, we'll be discussing lambda expressions, the map and filter functions, as well as just various methods you can use on different data types in Python. Let's go ahead and jump back to Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. Last time we left off on discussing how you can create your own functions in Python. Now what we're going to do is discuss the map and filter functions, and then how we can use lambda expressions instead of writing a full function out. Let me go ahead and quickly review how to write a function. You just use the keyword def for def, the function name. In this case, I'm going to call this function times2. It'll accept some variable as an argument, var, and then it will just go ahead and return that variable multiplied by 2, which means if I call times2 on a number such as 5, it returns 10. Now let's go ahead and discuss the map function. I'm going to make a sequence called seq, and it's going to be a list, 1, 2, 3, 4, 5. Now let's say I wanted to actually apply this function times2 to every single element in this list and then output the list. Well, I could use a for loop to do that and then append the results to another list. However, map is a built-in function in Python that allows you to save that step. If you go ahead and type in map, you can do Shift-Enter to actually see the documentation string for map, but basically it's going to create an iterator that computes the function using arguments from each of the iterables. Let me go ahead and explain just in kind of a clear, simple English what that actually means. You're going to say map, pass in a function, for instance, times2, and then the sequence you want to map that function to. And if you run that, it'll report back that you have a map at this particular place in memory. If you actually want to execute this map and get the result back as a list, you cast this into a list by using the built-in list function. And then this will finally return this function mapped to every element in that sequence and return it as a list. And now we can see that we have every element multiplied by 2. So now we have 2, 4, 6, 8, 10 instead of 1, 2, 3, 4, 5. Okay, so you may be wondering, do I have to completely define a full function such as times2, or is there an easier way to go about this? Because usually when you're using something like map, you're not going to actually want to write and define an entire function. This will probably just be a one-time thing. And that's where the lambda expression comes into play. I'm going to show you how we can rewrite this function def times 2 into a lambda expression. I'm going to slowly just break it down. This function times 2 can actually be written on one line. Def times 2 var colon return var times 2. And if I run these two cells again, it still works out just fine. A lambda expression will try to replicate this sort of structure, except it's going to remove words that we don't need. By default, when you kind of think about it, you don't really need def or return because those are kind of just given values. Of course, in a function, you're going to have to define it, name it, and return it. For a lambda expression, otherwise known as an anonymous function, you just want to replace in an instance where you don't want to have to define an entire function with just a lambda expression. And you can do that by essentially writing out this function, but getting rid of def and the name, and instead just typing in lambda. And then you'll go ahead and get rid of return and just type out what you actually want to return. And this is a lambda expression. Now I could, if I wanted to, say t is equal to this lambda expression, and then call t of some number, such as 6, and I can see that I get in return 6 times 2. So you usually wouldn't use a lambda expression like this, but it is possible to use it. What you will be using a lambda expression is for something like map, where instead of having to define an entire function, you would just type in a lambda expression here. You would say lambda, what you actually want to pass in, colon, and then what you want to return out. In this case, let's go ahead and multiply everything by 3. And now if I run this on the same sequence, I've grabbed every element in this sequence and multiplied it by 3. and I no longer have to define an entire function formally. I can just use a lambda expression. Lambda expressions are something we're going to use a lot, especially when we start learning about the pandas library. So if you have any questions on this, please feel free to post to the Q&A forums. But it's basically just a way of rewriting an entire function into a single line of clean code. And the reason for this is because you usually don't want to have to write and define an entire function. However, that always is an option for you. If you're ever confused by lambda expressions, you can just define a formal function like we did for times2 and use that instead. Now let's go ahead and discuss the built-in filter function. Filter is going to have a very similar structure to map, but instead of mapping a function to every element in a sequence, we will filter out elements from a sequence. Let me go ahead and show you how you can do this. You'll go ahead and call filter, and then you're going to pass in either a function or a lambda expression that filters out and returns Boolean values. So for instance, I can say lambda of a number, colon, that number mod 2 equals 0, and then pass in the sequence. And this will return just the filter expression. If I actually want to get the results back, I need to cast it to a list. And this returns back only the even numbers in my sequence, 2 and 4. So let's break down what's actually happening here. I'm saying filter, and this lambda expression takes in a number and returns a conditional true or false value based off some sort of conditional operation. So a filter must be using some sort of function or lambda expression that returns a Boolean value, true or false. And then what you're going to go ahead and do is pass it into an iterable object, and when you call list on it, it will only return the values where this statement happened to be true. In this case, we just filtered out for even numbers. Alright, now let's go ahead and discuss methods. Methods are essentially just calls you can make off an object that will affect the object or return a result in some manner. Let me go ahead and show you what I mean. I'm going to make a string called s, and this will say something like, hello, my name is capital S A-M, Sam. I can call s and then dot, and if I click tab in Jupyter Notebook, I will get a result of all the available, tab, scroll down, I'll get a result of all the available methods on this string object. Now we don't have time to go over all of these, and all of these won't be used throughout the course. We'll just use quite a few of them. Let me go ahead and show you the important ones. Lower will lowercase every single letter in a string. And note that you have to call it with closed parentheses. If you just call lower like this, it'll return back and say, oh, you're asking about the function lower. Like I mentioned earlier, you have to actually execute it by closing those parentheses. If you want to do the opposite, in this case uppercase everything, you can just call s.upper. Alright, one other useful function, or method, for strings is the split method. The split method by default will split a string on all the white space of that string. So note here we have hello, my name is Sam. When we say s.split, it will split this on all the white space. That's going to be really useful for text analysis later on in this course. Let me go ahead and show you an example. Let's say we have a tweet that says something like, go sports, hashtag sports. If we say tweet.split, this will split the text into a list based off the white space. But we can actually pass in a string into split to split on particular elements or characters. If I pass in hashtag and run this, it will split the string where it finds a hashtag, meaning it'll have the message and then at the end have a hashtag. And this will actually return a list that we can then index. So if I just want to grab the hashtag, I can say brackets 1 and it'll return sports. So we can already see how this would be useful if you just wanted to grab hashtags from some example tweet strings. Okay, those are useful methods for a string, upper, lower, and split. Those are the ones we're going to be using throughout the course. let me show you something you can do with dictionaries. So remember a dictionary, let's go ahead and see if we have an old one. Well, let me reassign this then to be K1 with a value of 1, and then we'll say K2 is a key with a value of 2. All right, so here's my dictionary. K1 is 1, K2 is 2. Now we can say d dot, and you can click tab to see the various methods available to you. Some useful ones are the keys method, and this just returns the keys of the dictionary. If you ask for items, this returns the dictionary items. And then we can also just ask for, if we look at D, you can say pop or get or values. So if you just want the values of the dictionary, this returns the values. Keep in mind, dictionaries don't retain an order. We won't really be using keys, items, or values throughout the course, but I do want you to be aware of them. Some useful methods for lists. I'm going to go ahead and make a list, LST, say 1, 2, 3. You can pop an item off a list by calling pop, and this will pop and return the last item in the list. And then when you call a list, that change is permanent, which means if we go ahead and say list is 1, 2, 3, 4, 5, you can say item is equal to LST pop, and that will pop the last item off of that list. And if we call that item, it's been reassigned. 5 is now item, which was the list.pop. And you can actually, with the pop method, pass in an index value to pop off. So if you say first is equal to lst.pop0 and run this, take a look at lst. Now the index 0 has been popped off, and our first variable is that 1, which was the first element. So pop is a really useful method, and so is append, but we've actually already seen that. That just allows you to append a new item to the end of a list. All right, finally, a few more things I want to show you is the in operator. So if you want to check if something is inside of a list, you can say the thing you want to check, and then in, and then the list itself. So x in 1, 2, 3, that returns false, versus x in a list containing x, y, and z, that returns true. And finally, the very last thing in this Python crash course that we're going to cover is tuple unpacking. Tuple unpacking is a really neat feature, and I'm going to show you how it works. Imagine that you have a variable x, which contains a list of tuples. We'll have 1, 2, 3, 4, and then 5, 6. So here, if I look at x, the first item in x is a tuple of 1 and 2. And I can actually grab items from that tuple. So I can grab 1, or I can grab 2. I can also do something called tuple unpacking. And that's going to work when we're iterating through a list of tuples. This sort of formation of a list of tuples is really common in Python, and a lot of functions will return a result in this format, which is why we have tuple unpacking as an option. So we can say for item in x, print item. And when I run that, it goes ahead and prints all the tuples for me. Tuple unpacking allows me to actually unpack these tuples as I go along. So I can do something like this. For a comma b in x, print a. And now this will print 1, 3, 5. Or if I say print b, this will print the second item in those tuples, 2, 4, 6. And that's tuple unpacking, where instead of just saying an item, you actually unpack this tuple inside of that for loop. And something else to note is that these parentheses surrounding this are actually just a formality. This is how you're going to see tuple unpacking in the real world all the time. You'll see for the tuple unpacking in x, which is some iterable of tuples inside of it, and then you can just print off the individual items in that tuple. And that's how you can do it. All right. We will remind you of tuple unpacking when we reach it again later in this course. It's not going to come up until a while from now, but hopefully this was enough of a general overview for Python. If any of this seemed just impossibly hard or was just completely unfamiliar to you and you really didn't understand the concept, this course may be too advanced for you and you may be in need of a course that's geared towards beginner in programming, such as my complete Python bootcamp course. Always feel free to post any questions to the Q&A forums, and coming up next is an exercise to just test your knowledge in this Python Crash Course topic series. Thanks everyone, and I'll see you at the next lecture.